When we look at temperature, the degrees Celsius is related to the degrees Fahrenheit. Okay? And if we were in America, we might want to convert some degrees Celsius into degrees Fahrenheit. So in this case, the way this function has been written, it's been written as my input is my degrees Celsius, my output is my Fahrenheit, or the independent variable is Celsius, and the dependent is Fahrenheit. Now, it could be easily the other way around. Again, if we were in Canada, and we are in Canada, but we may be given degrees Fahrenheit and we want to convert it into degrees Celsius. So then the Celsius would be dependent on the degrees Fahrenheit. But in this case, our input is Celsius, output is Fahrenheit. And when we take a look at this relationship, this graph shows this relationship. So at 0 degrees Celsius, it's approximately, looks like about 30 degrees Celsius. Okay, in fact, we can make a table of values to work that out. It looks like maybe, 80 degrees is about, 180 degrees Fahrenheit. Okay, and it looks like negative 0 degrees Fahrenheit is about negative 15 degrees Celsius. Okay, that seems about right. So we can use this graph then, this relationship as a graph, to determine the degrees Fahrenheit when it is 13 degrees Celsius. So 13 degrees is somewhere around here, so I'm just going to do this in a color. Okay, so 13 degrees Celsius is somewhere right about here. Okay, so there's my 13 degrees Celsius on my x-axis. And I go up to my graph. It looks like it's about, that's 20, 40, 60. So this, somewhere looks like maybe about 55 degrees Fahrenheit. Okay, so when it's 13 degrees Celsius outside, it's about 55 degrees Fahrenheit. So we can use this graph to figure this out. We could also use the function. So I can say the degrees Fahrenheit is equal to, and notice that this was just an estimate using the graph. But I can actually use the graph, the equation to calculate this value. So plugging in this into my calculator, so 9 times 13 divided by 5 plus 32, it gives me the degrees Fahrenheit. It's pretty close, as our graph was pretty close. It's 55.4 degrees Fahrenheit. Okay, so that's what I calculated using the equation. And again, it's consistent with the graph. So we can find any points along this line, so we found that one, by plugging into an equation. And in fact, what I've done then is by plugging into the equation, I've created a ordered pair. Okay, and in fact, I can find some other ordered pairs. So I'm curious, I want to know what 0 degrees Celsius is in Fahrenheit. Well, if I plug it into my equation, it's 32 degrees. Okay, so at 0, my ordered pair is 0, 32, so that's where it shows up on the graph. I could figure out what is body temperature. So body temperature is about 37 degrees Celsius. If I plug that into my calculator, so 9 divided by 5 times 37 plus 32 degrees Fahrenheit is going to give me about 98.6 degrees Fahrenheit. Okay, so 37 degrees, somewhere around here, is going to give us that point right there. So it's going to be 37 degrees, 98.6 degrees Fahrenheit. Okay, so that's about body temperature. And again, we can see from the graph that's consistent with what we get from the equation and what we get in our table of values. Okay, so we can always do this. We can always find points along this line by substituting into our equation, and that's always true regardless of whether it's a Fahrenheit Celsius problem. It could be an XY, just some general XY equation. When we get into more complex equations, that still is the case. We can always plug in x's to find y's in a table of values which relate to coordinates on the graph.